So I wanted to do some more examples on implicit differentiation. This was one of the examples we had worked on or looked at and not worked on it. I think one session we did, one we didn't. I know we didn't get to the second one below. So let's go ahead and do a couple of these. This is finding just y prime. So you differentiate both sides. So I was going to write this up, but I figured I might as well just make a video out of it. So d dx on both sides. Of course, that'll just be 1, and then d dx of sine xy. So left-hand side, that derivative is just 1. And then the chain rule, you could have dx dx, but that's just 1, so you're done. And then derivative of sine is cosine, so you say cosine of xy. And then it's times, this is where you have to be careful, then it's times, now you have to do chain rule with xy. So you basically have xy, and then you need to do the chain rule, which that then entails the product rule. So it's derivative of the first, which is just x, so it's just y. So derivative of the first, which is 1, times the second, which is y, plus the first, which is x, times the derivative of y, which is 1, and then you have to say y prime. Okay, so that's what, so if you did dx of this, that's what you'd get. Derivative of the first times the second plus the first times the derivative of the second, and then y prime because it's a function of x. So here we're solving for y prime still. And you have two separate factors. You got this factor and this whole thing. So you can distribute and then isolate. It's probably the best thing to do. So you have 1 equal to, I'll put y in front, y cosine xy plus x y prime cosine xy, just to put the formatting right. Now we'll bring over the 1 minus y cosine xy, so 1 minus y cosine xy equal to x y prime cosine xy, and that's all together. You could put parentheses around that. And then divide. We'll put y prime on the left-hand side, so y prime is equal to 1 minus y cosine xy all over x cosine xy. And so your y prime is isolated. I'm just going to move this down. Just we don't want to take that with it. Like that. Okay, let's try this one. So this is find the slope of the tangent line at that point. So let's work this one out. And this one is actually a special curve. It's called the limnoscate of Bernoulli, and it's basically looks like this. Oops. Well, this I'm not going to draw it. So it looks like this on a diagonal. Don't need to know the graph. And then in this case, they actually give you a. So we're just going to substitute an a. That was just sort of there, just to kind of make it look nice. But that's that's given. So let's go ahead and substitute it first, and we get this. So let's just go ahead and do that. That's going to be 2 times the other 2 is 4. So we'll just say that's equal to 4xy, just to simplify it. So of course we're not going to substitute 1 yet, because we don't know what that, I mean, they'll just zero out everything. So we don't want to do that. You want to go ahead and take the derivative of both sides implicitly, and then we will solve for y prime. Once you have y prime, or we can substitute once we have y prime in there, and then we will be able to find the slope. So basically, find the slope. So basically, what that's asking then is, sorry, there we go, is find y prime. Now, it may not necessarily need to isolate that, but we need to find it. So we're gonna do, I'll write it out, d dx of all of this, x squared plus y squared. Is that all it was? Oh, that was squared. I was going to say, I don't know why I had parentheses there. So that'll require chain rule and then derivative of the inside stuff as well. And then dx of 4xy. And as usual, this 4 just comes out. Like when you're doing a derivative, you're really just taking a limit. So all those limit properties hold. And so you just take out the constant. It's only when you have like a plus 4 and you do a derivative like that becomes 0. Okay, so left-hand side is going to be 2 times what's inside. Subtract 1, so it's just 1, times the derivative of what's inside. So that's 2x plus 2y, y prime. And then that's equal to, and then now this derivative will be a 4 times, and then that requires the product rule as well. So it's derivative of, so it's the same as the other one we just did. Derivative of the first times the second, plus the first times the derivative of the second, and then y prime. So now we need to get y prime on both sides. So what we're going to do now, and then let's see. Well, actually at this stage, we may want to just substitute because you have all of this mess and all of this. And so if we substitute now for 1, 1, x, y is 1, 1, it'll be a lot easier to solve for our y prime. So let's just do that. So you can evaluate this. This is an evaluation bar at 1, 1. Oops, not that. You can evaluate this at 1, 1. So it's 2 times 1 plus 1 times, and that'll be a 2 plus 2y prime equal to 4 times 1 plus y prime. And let's double check that when we substitute. So here's a 1 and a 1. There's a 2, and there's a 2, and then a 1, and then a 1. Okay, looks good. So this is going to be 4 times 2 plus 2y prime equal to 4 times 1 plus y prime. And then we're just solving that for y prime. So you're just going to simplify. Now you can divide out by 4. Just make this simple. So you just have 2 plus 2y prime equal to 1 plus y prime. And so we subtract y prime on both sides. So y prime is equal to -1. So here our solution is -1. Okay, and so that covers both of those. And I think we're going to do some more on a different section next. Okay, so there you go.